Hello everyone. Today we will see how we can formulate a solver in OpenFOAM. This is the introduction of a solver formulation in OpenFOAM. We can see how we can build a solver. So now these are the topics which we will cover here in this tutorial. So basically we have the introduction mean, but what are the steps we will follow here. So there are the and what are the solver detail, how we can formulate a solver. Basically there are two methods we can create the solver, new solver. So like first method, we have the exercise solver in the source code. So then based on that we can modify the solver. Other than we can use we can build a solver from the scrap. From the scrap mean we can use some utility, so we can form a template, then we can add the some field variables and equation, how we can solve the equation. So base and we have the solver case. We have the we have solver case, and we can solve a problem by using this solver. So in first, as I said, we will basically the purpose of to show this tutorial. So how we can formulate a solver, how can set up a how can set up a problem. So based on that we can build a solver, and we will try to solve that equation which we have created that solver. So basically, like, we can identify the equation. Basically we have the set of equations, like it depend on the which problem we are going to solve. Suppose sometime we need to solve the flow equations, like we have the momentum equation, continuity equation. Basically there's flow equations. So we can sometime we can include the energy equations, like, yeah. So it's basically user specific, what you are going to solve. Yeah, so based on that we can build a solver. So these are the following steps. First we can identify the equation, so then we can write the brief explanation how we can build, like in this problem we have I have created one solver, myTFOAM. Basically here only we are going to solve the temperature equation. So that's what I just mentioned, the name is T equation. So we will see the later on. Then we will set a case problem, then how we can solve this equation, so we can have the in a steady state solution or unsteady state solution. Set up the properties of the fluid, like which fluid you are going to consider, like air, water, whatever you want. So then based on that we can set up the property of the fluid, and yes, and we will set up the initial condition, boundary conditions. So and numerical schemes and solver parameter and some control parameter we can see, and yeah. So this is the solver detail. I said they I initially I said that there are two ways to build a solver. First, either we can copy a solver. So either we can copy existing solver, then based on that we can identify and we can copy that existing solver to the working directory. Where do you want to save? Is basically user specific. So these are the step I have mentioned here. So first method, create solver creation by with modification of existing solver. Like these are the following steps we have to follow. First, be run command, so we can go to the run directory, and it depend on the which OpenFOAM version you are installing, yeah, you are using. So based on then you can source that version, so of OpenFOAM, then try to follow these steps. So like I have mentioned here, like initial run command, then we can and we can move to say, like we can make a some like this solver kind of, just first you have to go to the run directory, just and create the solver. So and solver directory, then go to the solver directory, just copy the source code like this one, from this from this mm, already existing solvers. So these are the step, like I have mentioned here, the user space, user form. Basically it's depend on your user specific what you want to go, so you can put your name also, so that depend on your, yeah. Next mm, next solver creation, and then what are the, after that, after you can modify it and basically clean the directory, then just clean the directory and rename your the solver like that. You have to follow the, those are the steps. So and after that you have to set up all the like you have to modify, suppose you have to have some equations, so and it equations like for the suppose you want to solve the temperature, then you have to have the temperature as a field variable. So do you have to create the field in the field, create the create dot fields dot h file, so that header file. So do you have to add that the temperature, so and we will see that in some files I have mentioned here. So say these are the following, basically you can follow these are the steps. So second step is that when we have the some utility, so it will what it will create the template for the solver which you are going to create newly as per your requirement, as per your specification what you are going to solve. So that based on that you can create that, just like some for some steps, some for some steps you can follow the as previous I said. So go to the run directory and then make it basically is based on your choice. So then there is like there is a utility form app, basically it will create the template for the your application like solver which you are going to form. And so like you have execute, just type form new app and space user form, basically you can give the any name which you want. So then after that it will your name by this name user specific, the template will create the there is a there is a two there are just once where is that one second, there is some come you have to change it. So like what is the benefit also, benefit is when you are using this open form utility, form this form new app utility, and yes, also in the some few on the few occasions. So these are the two methods which we have. So we can create any solver like here, yeah. So these are the you follow. You can follow these step. You can form a new solver based on what you are going to solve with this solve by using OpenFOAM. So like this is the solver modification or solver creation. Second pass, suppose for example in this case we have created one solver. So like TFOAM, basically we have the equation. I'll show you the which equation we are going to solve. So suppose we have like the I have I actually earlier I said this mean um, you have two options. Either you can copy, there is existing source existing solver which is available in the source code of OpenFOAM. Either you can use the utility. So based on that is up to you which method you are going to solve, going to use. So and I mentioned here just copy and modified it first step. Second, then you can use this foamNewApp utility. So like if you have you can you execute form new app space myT. Basically myTFOAM is the which my new new solver, which new app or new solver whatever you call, which I'm going to create it. So we can define it and we can execute it. So that kind of as you can see the structure of the solver, it will be created like that, and what is the what is the advantage of this when we use it? Then we don't need to change that this, like I'll show you the next file, some few file. So basically, we have the created the field here. So this is the structure of newly formed myTFOAM. So we have the create which we have the header file which is containing this stuff, all field variables, and myTFOAM it which equation we are going to solve. Then these are the executing. So some options, like we can include some file. So and these are the files which include the executive. So you can see, I'll tell you, I will show in the next slide. So first, I said this create the field. So this file you can look. First we have to we have to define the transport properties. So these input output object, we can define transport property. As we can show the structure of this, the way the standard structure of the OpenFOAM cases, we have the three directory: zero directory, and system directory, and constant directory. System directory, it contains the scheme file, solution file, and control file. So and constant file, it is having the mesh information and transport properties. And zero folder zero time directory, it having the initially defined field variable. So these are the things. So in this myTFOAM we have the I'll show that, we have to define the some parameter like alpha, basically thermal diffusivity here. So and temperature, basically this is the volume scalar field. Temperature is a scalar field, yes. So we have defined the temperature only. Here only we are going to solve the temperature equation, nothing else. That's what we don't have here. Pressure and velocities parameters here. So field variables here. So we have only the temperature and some properties like thermal diffusivity. So when you execute this foamNewApp utility, then it will create and this description you will get by default, like this application this description you have to add. If you want to specify what are these about the solver, what are the what is what are you going to solve, like which kind of solver, and which kind of like Newtonian fluid or not Newtonian, you can mention here the dimension description of that solver. So basically I have created this one myTFOAM. And what are you going to solve with the equation? Just I have mentioned here, suppose I have the temperature equation like this one. So like temperature equation is this, basically this equation: dt by dt d capital T dt by dt dou t by dou t is equal to alpha d dou square t by dou x square, like that. We have this equation, basically the heat equation. So yes, so now we are going to solve this equation. So basically here, we have written in the, there is a two way to write the equation. Either you can solve, either you can save in another file this equation, like that. After that you can include you can call into this file, main solver file. And either you can define here, there are two way to define the equation. So basically here we are going to solve this equation. So equation, that's what we have only the temperature equation here. We don't have the pressure and velocity here, because only we have considered the time equation here, temperature equation, basically energy equation. So that is the thing. And the executor, like I mentioned, the make and make or like, then we have this then what is the main advantage of, then when you use this new app utility, then this already this function, this environmental value you don't need to change, because this is the user directory. When you use this method first to create the solver, so that you will see when you have the, like, you copy the source code, then you don't have this so you have to change it, because the user is specific, so then you have to change that in specify one. And in method one, when you are using second and form new app utility, then you don't need to change, it will take care of itself, because that is, yeah, that, so that is the like, if you don't change, you don't need to change this. So that is the advantage of this. Basically this is the, and build how you can build the solver. Just we clean the directory, then after that you we make just execute, we get the solver is start building, and finally you will see that that solver is completely built. So based on that, we have solved we have solved the one equation, like I said, the dt this equation. So this equation dty d, basically dt temperature, y is more t the time. So dty dt is equal to alpha d square y d square ty d square x, like you can say, yeah, x square. So like we have the this zero, we have the temperature, we have the temperature field only, because then we have like yeah, and constant, we have the transport property, like alpha you need to define here, alpha thermal diffusivity. After that you have to we have the, basically this is the structure, this is a case structure. So then it contain this temperature, this time directory, constant folder, and system it has the mesh information, so you can create the mesh file. So by using the blockman, then it had the all the time information and solver information. And FB schemes, here you have to define which schemes you are going to choose here. So then all the information are, and it is a solver information, PV solution, the solver information are mentioned here. And this is the structure. Then you can see each file in detail. So like zero folder, constant, what it is. So basically this temperature we can define like that, temperature we have defined that, like we have the slab. So this equation, basically we have the slab like that, then slab it having the temperature and some surround yes, some temperature at the upper, then these are the some adiabatic condition we are applying. So so then you can see basically, yes. Yes, and we have defined the constant property, transport property in the constant folder. So we, as we like said, we have defined this alpha thermal diffusivity. So in constant we have the this block mass. Basically, this is the standard tutorial we can copy and modify based on that. So yeah, these are the mesh file information. You can create the mesh by using this block mesh utility, or you have to define the geometric parameter, geometric information to here. So and boundary condition. So and now after that we have this, like we are solving this mighty, you have to call when you are going to solve this slab, what the kind of the temperature changes in the slab. So basically the solid slab. So yeah, and you are using this myTFOAM. So basically all the information, yes, these are the some scheme like earlier, basically unsteady state problem is this, right? And we have used this gradient, which scheme, gradient and scheme you are using for temperature, we are using the Gauss elimination, linear equation, so linearization. So then we have the tab scheme, because in this our equation we don't have the this term in our equation, we have the only the Laplacian equation, like Laplacian, yeah. So Laplacian equation, so we have alpha and t, so we have using the classical character scheme, yes. So these are all information FB solution, which solver we have used here. We for the temp, like solver for the temperature we have used the small solver used, yes. And smooth, yeah, you can Yeah, and these are the basic. Basically here what I have described, the basically the whole procedure. Basically this is the only the purpose to demonstrate how we can build the solver, and how we can build a solver, and then and you can solve some problem by using, or why created solver. So you can understand how the how you can follow the steps to solve a equations, to solve a problem. So you have the problem, like I mentioned, there is a one equation like which and we have considered one problem, like we have the slab. So it has the different temperature at the, like we have the square like cavity form. There is some tutorial the cavity, so that equation you can copy and you can see the like this is the, that is the cavity. But here we have the solid slab. So basically it has the different one mm, hole at the boundary, you can mention here fixed ball, moving ball, and fixed ball, moving ball, and front and back. Front and back basically there's no gradient, just because we have solved only the 2D equations here. So and you can see what are the boundary condition we have in the zero directory, right here. Constant, yes, like we have mentioned here, the this moving ball mean top ball is a 42 degree temperature, and fixed wall also 42-degree temperature. Basically all wall are 42 temperature, 42-degree temperature. Then what happened, the energy transfer from side from the from the wall, fixed wall, from the fixed wall of the slab to center, towards the center. You can see the how, what kind of the temperature distribution you will get it. So basically that in this demonstration you can see the process how we can formulate a solver and solve some equations. So if you want to know more, you can write to me and command it. So, and basically I have the made a separate tutorial for that, so you can have the video for that. You can have a look that video which I have in a separate tutorial for that. Basically in here you have the you can see the whole step which is documented here. So that is the purpose to show here. So please follow all the step and try to understand, and try to build yourself based on your problem, your problem which you are going to solve. Build a solver based on your problem. Second, then you can try to solve that some example or some equation. Like you have whatever equation you are, whatever problem you are going to solve is basically is user specific. So you can build your own solver, then try to solve some equation. So you will get the some you will get some information how we can build a solver in OpenFOAM, and how we can solve some problem. So that is the purpose to show here. Thank you for watching.